This is a huge discovery, and we think that it's a huge discovery.
Have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find because it's the nearest star to the Sun.
This is a huge discovery, and we think it's a huge discovery to have found a terrestrial planet orbiting Proxima Centauri, the nearest exoplanet we will ever find, because it's the closest star to the Sun. What the James Webb Space Telescope found that no one expected was city lights in space, 7 trillion miles from Earth. This amazing discovery has made people wonder if there is life on other planets. The telescope focused on Proxima Centauri B, which is the nearest star to Earth, and showed that it was giving off strangely bright lights. What could be making these lights on Proxima Centauri B look like city lights? Could this be a sign that there is life beyond Earth? Come with us as we look into how the James Webb Telescope found these strange things in space. Scientists and people in general have been waiting and studying for years to catch a glimpse of life outside of our solar system. Any proof that this space fantasy is true has been received with open arms. Scientists got the biggest surprise of their lives not long ago when the James Webb Space Telescope saw solid proof that there are living things in space. The James Webb Space Telescope was looking into space and sending important data back to Earth when it saw strange lights that looked like they came from the world Proxima Centauri B. These lights looked like they were lighting up a faraway city. Scientists are shocked at the thought of an alien city possibly existing on Earth. Each of them is confused because this life seems to be the one they've all been waiting for. If this turns out to be true, it means that intelligent life forms in space are running societies that are very different from what humans know, and we're just now finding out about them. When NASA engineers look at the city lights 7 trillion miles away from Earth, they can't help but wonder how long these lights have been there waiting for people to make the technology to see them. David Kipping, a scientist at Columbia University, says that the Proxima B exoplanet is hard to understand because it has city lights. He said that because the heating patterns in the star system are different from those on other worlds, it is known that most rocky planets take in sunlight and give off infrared energy, but not for this world. Its infrared nature is very different from that of its star, which is called Proxima Centauri. The James Webb Space Telescope, JWST, was able to make a good study with this. It was the right tool for the job. Infrared bands are easy for the JWST to pick up. The unique heat signature of Proxima B will help us learn a lot about the atmosphere of other planets because the JWST has the most up-to-date infrared imaging equipment. Scientists hope to use the telescope to find out more about the mysteries of this planet's atmosphere. They also want to find out if it's possible to live on this extrasolar world. With its infrared sensitivity, the James Webb Telescope is ready to find out what happens at night on Proxima Centauri B. Most space cameras have trouble picking up the faintest rays of light in the vastness of space, but the JWST can see even the tiniest rays of light from space. It's the perfect tool to find out if the reports about city lights on the night side of Proxima B are true. All man-made lights in the universe can be picked up by the telescope as long as they are within a frequency range 1,000 times smaller than sunlight. The way Proxima's stellar features combine with its surface is very interesting. On the day side of the exoplanet, there are a lot of solar screens that collect the star's beaming energy. The spectra edge also bounces light back into space. When Proxima B finishes its circle around its host star, Proxima Centauri, it has day and night cycles like we do here on Earth, with the sun heating up the day and cooling things down at night. It is known that the planet's temperature changes because of what it is made of. In this case, Proxima B will have a huge difference between day and night if it doesn't have an atmosphere. If it weren't for the seas and gases in the atmosphere, the day side would be as hot as a black body, and the night side would be completely dark and freezing. Astronomers are very interested in studying how much the temperatures change in order to learn more about Proxima B's atmosphere. The JWST can quickly look at the planet's heat emissions, giving us useful information about its atmosphere thanks to its unmatched infrared imaging abilities. It's interesting that the James Webb Telescope's orbit around Earth lines up with Proxima B's orbital period. This means that its day and night periods can be fully observed in 11.2 Earth days. Since Proxima B probably has an atmosphere, the next step is to look at the chemistry of that atmosphere to see if it can support life. Gases like oxygen, water vapor, and methane are important signs that a place is habitable. If these elements are found on the planet, it might mean that it has conditions that make it livable. But scientists have to pay very close attention as they record and study light rays as they pass through the planet's atmosphere in order to figure this out. Even though the JWST is very good at describing the atmospheres of planets, it is not very good at finding bound oxygen, which is a key sign of life. Even with these problems, the camera can still look for other things in the atmosphere, like ozone, which also shows signs of life. Another important thing to keep in mind is that the James Webb Space Telescope can only look at a few of the closest livable worlds to Earth. Astronomers are looking forward to ground-based telescopes like the Extremely Large Telescope, ELT, which will start working in 2028, so they can do a more in-depth study of the atmosphere. The ELT will be able to look more closely into the atmospheres of faraway exoplanets, gathering information that will help us understand how habitable those worlds might be. But until then, the James Webb Space Telescope is still an important tool for us to use as we try to figure out what strange things happen on faraway exoplanets. Even though it has some problems, the Webb telescope could still change the way we think about exploring other planets both now and in the future. The main goal for future space telescopes is to cut down on the bright light that comes from a planet's star host. This will help scientists see the planet's faint light reflections better. To do this, they plan to use internal masks or big external satellites that look like shields, like how you cover your eyes from the sun to see things better. Future telescopes will be able to study faint light reflections from faraway exoplanets better because host stars will give off less bright light. This will allow for a more in-depth study of their atmospheres and their ability to support life. However, this process has some problems, such as the need to tell the difference between gases made by living things and gases made by natural processes like volcanoes. Astronomers are still driven to learn more about exoplanets and tell the difference between real signs of life and false ones. The Webb telescope's work on exoplanets gives us a sneak peek at the amazing findings that are still to come in science. As our exploration of space continues, we learn more about how the world works and where we fit in it. Scientists have been looking through space for decades, but still haven't found solid proof of life beyond Earth. However, the search for other kinds of life goes on. People have been wondering for a very long time if they are the only ones in the world. Today, scientists use the James Webb Telescope to look for signs of life on other planets and hidden alien societies. This question has been around for a very long time. A common story says that aliens are waiting to be found out there in the stars. The Search for Extraterrestrial Intelligence, SETI, Institute was founded in 1984 by Jill Tarter and Thomas Pearson, two American scientists, to look into this idea. SETI is a non-profit group whose mission is to search the universe for radio messages coming from space. For generations, humanity has pondered one of the most profound questions. Are we alone in the universe? Curiosity about extraterrestrial life has fueled countless theories, stories, and scientific pursuits, and today, the search for intelligent life has become an active field of research. Among the pioneering efforts is the Search for Extraterrestrial Intelligence, SETI Institute, established in 1984 by two American scientists, Jill Tarter and Thomas Pearson. The foundation of SETI marked a milestone in the systematic search for alien civilizations beyond our solar system. This non-profit organization was created with the ambitious mission of scanning the cosmos for any signals or radio messages that might hint at the existence of intelligent life. SETI's approach is centered on monitoring specific radio frequencies for possible transmissions, as radio waves can travel vast distances across space with minimal interference or loss of strength. The organization continues to develop innovative technologies to enhance its search, and the commitment of its researchers has placed it at the forefront of extraterrestrial intelligence exploration. After nearly 4 decades, SETI has not yet found conclusive evidence of alien communications, but it remains one of the most promising efforts to answer the age-old question of life beyond Earth. The hope is that, with continued advancements in detection technology and expanding global interest, new discoveries will come to light, offering unprecedented insights into our place in the universe.